what's up, guys? What's going on? Hey, I'm going to go over 11.1 and 11.2. I'm going to give you the quick check solutions, and then I'm going to go over the quiz review as well, all right? So hopefully this will help you prepare for the actual quiz. All right, first looking at the quick check, guys. With this quick check, let's go through these terms. All right. They called every 50th person on a list of registered voters in the state. Well, guys, systematic. All right, systematic. All right, because there's a system here to this. All right, let me rewrite that. Systematic. All right. Then it says they randomly select voters from each county. All right. Well, since they broke it into different groups, you have either cluster or stratified. But because they randomly select voters from each group, all right, this is stratified. All right, not cluster. Cluster, you would choose a whole group. All right. And then they ask every person who comes to the next campaign rally to fill out a survey. Well, they're already there, guys. That's convenience. All right. Convenience, okay? Now, this next example is a margin of error problem. Make sure y'all read it. But it says, does the survey clearly show majority preference? All right. Well, first you got to find the range. All right. So if the margin of error is 4%, for yes, it would be 50 to 50. Excuse me, to 60. 60%, and this one would be 40 to 48%. All right. Now the key word here is overlap. All right. Does this contain overlap or not? The range does not. There's no overlap. All right. No overlap. So there is a clear preference. All right, and the preference is of yes. All right, clear preference of yes. All right. So make sure you show the range and then discuss overlap. All right. Now, for these problems right here, we have the sampling distribution. All right. Well, make sure you're specific, man. So for this first one, all right, this will be a normal CDF. All right. And then remember, guys, you always got to go normal CDF of lower bound, upper bound, the mean, and then the standard deviation. Okay. So in this case right here, the mean is 432, the standard deviation is 36. So for this problem right here, it says you drive more than 450 miles. More than. So 450 is your lower bound. All right. So you go 450. All right. You can just go up, whatever, 1,000, 10,000, who cares? You know what I'm saying? Just pick something that's significant. All right. 432 and then 36. And when you put that in, guys, we always want 5 decimal places. All right. Five decimal places. All right. 5 numbers after the decimal. So when you do that, you actually get 0.3085. All right. Or you could put 30.85%. You can put that as a percentage. All right. For this next one, between 400 and 440. All right. Again, you have normal CDF. All right, and you're going to go 400 to 440 because they gave it to us. All right, again, you put the mean and then the standard deviation. All right, oh, I'm sorry, 36. That's actually 36. Let's put that. Like so. All right, and when you do that, again, look at 5 decimal places, round it back to 4, and you get 0.4009. All right, it was 0.40089, but the 9 rounded the 8 to a 9, so 4 decimal places, always 4. All right, or you could put 40.09%. Then this last one right here, no more than 375. Well, that's the upper bound. So the lower bound, I'm just going to put 0. No more than 375. All right, when you do that, it's going to give you 0.0567. All right, or you could put 5.67%. Okay. All right, that's the quick check, guys. I just wanted to go over that with you. Make sure you understand that, guys, it's 4 decimal places. If you don't do that, I'm going to hit you. All right. And I don't mean literally hit you. I mean, I'm going to hit you with points, man. You got to give me 4 decimal places on that. That's what we're practicing, okay? Now, I'm going to move on to the review. All right. Here's the review. So let's go ahead and work through it. What type of sampling method is the most accurate? Guys, random sampling. All right, or simple random. Let's say that, simple random. Because again, man, this represents the whole population. All right, and everybody has an equal opportunity of being selected. All right, so simple random. And what type of sampling methods are the least accurate? All right, we're going to say convenience. Convenience. All right, because one, you're just sampling the people that's around. All right, they don't actually represent the population. It's just easier to do. All right, and the other one is going to be self-selected. And again, self-selected. All right, again, I said types. Self-selected is because again, these people feel strongly about their views. All right, so they're gonna be biased to either really for it or really against it. Okay. What type of sampling method is described? All right, in this first example, right here, a survey of students, favorite school subjects being conducted, every 5th student. All right, in the math club membership list is asked, what school subject is your favorite? All right, so this is going to be an example of stratified. All right. All right, because they're selecting every 5th student in the math club. All right. And also, I think it is going to be systematic. It's stratified because all right, they picked out the math club students, so they broke them into groups. They went to the math club, all right, and was like, "Hey guys, what is your favorite subject?" All right, but then it's systematic as well because they chose every 5th student. All right, stratified because they broke it into specific groups. They said we're specifically asked the math club, right, out of all the students in the school. And then within that, systematic because they picked every 5th student in the math club, okay? Now, this next one says a team wants to know who the fans think was the team's MVP during the season. Fans can vote on the team's website. Well, that's going to be self-selected. All right, and that's self-selected because obviously it's a website. So if you want to comment on it or you want to vote, then you got to go to the website, you know what I'm saying, and cast your vote. It's not like they randomly caught you somewhere, etc. So you volunteer to go vote, all right? Next, the manager of a company with 200 employees wants to know how the employees feel about some proposed changes. The manager used a computer to generate a list of 40 employees to survey from a database that includes all employees. Well, this is going to be simple and random. All right, and again, it's random All right. Again, it represents all employees. There's 200 employees. All of them are in the list. Everybody had an equal chance to be chosen. They chose 40. That's simple random. 40 would be the sample size. All right. A customer advocacy group wants to know if a car owner believes their car is reliable. The group randomly selects 1,020 car owners and mails out a survey. All right. With that, it is probably going to be self-selected as well. All right. Because again, although they're sending you the survey, it's still your option to do it or not. You know, you don't have to do it. You know, them choosing randomly 1,020 people out of their well, they chose car owners. All right. So it's still self-selected. Even when you get it, you still got to choose to do it. All right. This next problem, you got both Michael and Hillary are running for president. A poll taken a week before the election showed that 47% were in favor of Hillary and 53% were in favor of Michael. All right, so the survey has a marginal error of 4%. Does this indicate which candidate will win the election and explain? Well, Hillary has 47% right now, right? But the marginal error is 4. So if we get a range, it's going to be 43 to 51. And for Michael, you're going to have a range of 49 to 57, right? So now, the question is there any overlap? All right, and yes, there's overlap. Yes, there's overlap because again, the overlap is 49, 50, and 51. All right, 49 is in between 43 and 51, and 51 is in between 49 and 57. There's overlap. All right, so because there's overlap, there's no clear winner. All right, there's no clear winner because of overlap. All right. Because of overlap, there's no clear winner. All right, you got to talk about overlap. All right, either there is overlap or there isn't. Take this next example. A bicycle company wants to know whether customers would prefer to carry more racing bikes or mountain bikes. All right. So the store polls its customers to find out that 56% of the customers prefer racing bikes, 44% prefer mountain bikes. The margin of error is 5%. So does it clearly project the preference? All right. So let's look at it. The mountain bike range is 44%, right? So the range would be 39 to 49. All right. And the racing bike is going to be 51 to 61. All right. So now, is there any overlap? There's no overlap. No overlap. All right. Unlike the other one up here, we had overlap, right? There was overlap, so no clear winner. Here, there's no overlap. So there is a clear preference. And the preference is going to be racing bikes. All right, racing bikes, okay? Again, there's no overlap. All right, overlap is the key word. All right, we got to label this deal here, man. You fill it in. All right, let me make it bigger so I can write on it. All right, here's what it looks like. Oops. All right, you have 34% right here. All right, then you have 13.5, and then you have 2.35, and then you have 0.15. All right. Ooh, let's fix that. 0.15. All right, it's on you guys. You got to make sure you learn this. All right, 13.5 2.35 and 0.15. Okay. Now, this right here will be mu. This is mu in the middle, the mean. All right, then this is 1 standard deviation over, 2 standard deviations, 3 standard deviations. All right, but that's in the positive direction. All right, so this whole side is going to be the positive direction. Over here, you have 1 standard deviation, 2 standard deviation, and 3 standard deviation. All right, but this is in the negative direction. All right, negative direction. All right, so label that up. And then we're going to use this to answer questions, okay? So if we look at the first question on the back, the first question says, what's the probability that X is greater? All right, this is the greater 2 sign. X is larger than mu plus 2 standard deviations. All right, so look, here's what you got to do. You got to go back to your table here. All right, and you're going to say, actually, hold on. I'm going to use this one. All right, it's a little neater, all right, than the other one. All right, so let me go back to the question. It says, what's the probability of X being greater than 2 standard deviations to the right? All right, mu plus 2 standard deviations to the right. So if we go to the right, all right, here's mu, go 2 standard deviations. This line right here represents 2 standard deviations to the right. This line, right? So you want X that is greater than that line, all right, which is all of that, greater than that line. So I would take those two right there, 2.35 and 0.15, and we're going to add them up. So 2.35 and 0.15. When we do that, that gives us 2.5. All right. So the answer here, the probability of X being greater than mu plus 2 standard deviations is 2.5. For this next one, you want a probability that is less than or equal to minus 3 standard deviations. All right. So I'm gonna go back over here. And I'm going to go minus 3 standard deviations. So here's mu, 1, 2, 3. Here's the 3 standard deviation line. And we want less than. All right. So there's only one thing out here, 0.15. All right. That line is minus 3 standard deviations. So 0.15. Oops. Let's change back. 0.15. All right. Percent. Put that percent. All right. Now we want the probability that we're between, X is between 1 standard deviation, that's positive 1 standard deviation, and positive 3 standard deviations. So let's go back over here. We want to be in between 1 standard deviation and positive 3 standard deviation. So again, this right here is the line for 1 standard deviation, right? And then this right here, 1, 2, 3. This is the line for 3 standard deviations. So we want the X in between. All right, that's all in between. So we add that up, 13.5 and 2.35. And that gives us 15.85%. All right. And then we're going to do between negative 1 standard deviation, minus 1 standard deviation, and plus 2 standard deviations. All right, so let's go back to this one. And again, we said minus 1 standard deviation, which is right here. And we said plus 3 standard deviations. So 1, 2, 3. That's 3 standard deviations. So we want all of this. Yep, all of this. So 34 and 34 is 68. All right, 68 plus 13.5. sorry, 34. 34 plus 34 plus 13.5 plus 2.35. All right, again, let me go back to it so you can see it. All right, minus 1 standard deviation. All right, then again, 3 standard deviations. All right, so there we go, plus 3 standard deviations, all of that. 2.35, 13.5, 34, 34. And that gives us 81.5. All right, just add that up, okay? All right, now this stuff right here, if the mean of the data set, the mean of the data set is 264 and the standard deviation is 9, find the following. All right, yo, you can use your calculator on all that, and I'm going to show you, okay? So this first example says, what's the probability of x being less than 255? Well, 255 is going to be my upper bound. All right, that's my upper bound. All right, remember we talked about it a second ago, but this is your upper bound, okay? So how we put that in our calculator is this. We're going to go second, and then distribution. That's what we're going to do. All right, let me do that again. All right, you go second, VARS distribution, and we're going to choose normal CDF. All right. So we said that's our upper bound. So we're going to let our mileage, all right. Or I'm sorry. We're going to let the lower bound be 0. All right, lower bound be 0, or you can pick something lower, doesn't matter. Negative 1,000, doesn't matter. The upper bound is going to be 255. All right, the mean was 264, and the standard deviation was 9. All right, anyway, it should look like this in your calculator. And then we hit enter. All right, again, we want 5 decimal places to round to 4. All right, 5 decimal places to round to 4. So here we're going to go with 0.1587. All right, 15.87%. All right. Now, let's look at the next one. The next one says, what's the probability of x being greater than 282, which means this is your lower bound. All right, think about x is larger than this, so that's the lower bound, 282. So back to our calculator. All right, second, normal CDF, and we're gonna go the lower bound. We said it was 282, right? So our upper bound will make something like 1,000. All right. Then the standard deviation was 264.9, so it looked like this. All right. Ooh, let me fix that real quick. I put 100. That's lower. That won't even make sense. We want that second one to be 1,000. There we go. Now hit enter on that. Alright, something went wrong. No, it didn't. Nope, yes it did. Something went wrong. Let's see what went wrong. See what went wrong? That's still 100. I don't know why that's still 100. Let me try one more time. CDF. Alright. 282. Alright, upper bound 1,000. Alright, 264 and 9. Alright, come on. There we go. Alright. So 5 decimal places to round to 4. So 0.0228. Alright, or you could put 2.28%. Alright, that's fine. Now this one, we already have the parameter. All right, the lower bound is 246. X is between 246 and 273. All right. So when I go normal CDF, all right, my lower bound was 246. All right, my upper bound is 273. All right, and then my my mu and my standard deviation are the same thing. All right, we get 81859, which means we round that 5 up to 6. All right. So again, we get 0.8186, or you could say 81.86%. Next, again, our boundaries are set for us, 237 and 264. All right, so back over here one more time. Normal CDF. All right, we got 237 to 264. All right, and all that's the same. All right, and again, 4987. All right, 0.4987. Or 49.87%. Wait, did I do that right? 0.498. Yep, 0.4987. All right. Now, let's look at E. Think about it, guys. The probability that X is at least. All right, at least. That means this is the smallest amount. That's your lower bound. At least 270. All right. Normal CDF. All right, we said at least 270. That's the lower bound. All right, so the upper bound can be, upwards 1,000, 10,000, whatever. All right, so 0.2525. All right, 0.2525. Or you could put 25.25%. All right, no more than 250 means that's the upper bound. No more than, that means that's the max. All right, so I'm gonna do that one, and then this one's between. So I'm gonna do those two for you real quick. All right, you go ahead and do them. All right, when I did them, I got 0.0599. All right, or 5.99%. And for this one, I got 0.5608, or you could put 56.08%. All right. Now for this one, it says what percentage of the normal distribution data set falls within 1 standard deviation, 2 standard deviation, and 3 standard deviation from the mean. All right, so let me go back over here to this other slide here. All right, the question is, what percentage falls in between 1 standard deviation, which is right here, 2 standard deviation, which is right here, and 3 standard deviation, which is right here. So they're saying what percentage falls in between all of this, from this one to this one. All right. Well, when you add all those up, guys, you will get a grand total of 97%. 99.7% actually. Oops, wrong way. All right, and if you don't remember, also it was in your notes. All right, I put it right here. 99.7 lies within 3 standard deviation. All right, so if you were here that day, you paid attention. Remember, it was 1 standard deviation, 2 standard deviations, 3 standard deviations. All right, 1 standard deviation is 68%. Don't forget that. 2 standard deviations is 95%. 3 standard deviations is 99.7%. Or if you know what I'm talking about, each line represents a deviation. 1, 2, 3, 1, 2, 3. If you know that you're in between 3 standard deviations, you can just add all those up, okay? All right, let's see here. The next problem. It says the weights of a sample of 24 apples from an orchard are given below in pounds. All right, so it's 24 scores right here, or 24 weights right here. If the mean is 0.5 and the standard deviation is 0.08, does this data appear to be a normal distribution? All right, and explain. All right, so wait a minute. Before I do that one, guys, I realized I skipped one. All right, this was 99.7 for 3 standard deviations, 99.7%. For number 10, all right, if your data set has a mean of 32, all right, and the standard deviation is 2.3, what interval does 68% of the data lie in? All right, 68%. So you got to go what interval? All right, well, this one you got to do some work, and I'm going to show you why. Back to this one. They said that the mean was 32. All right, and the standard deviation is 2.3. All right, so if the mean is 32, the first standard deviation would be 34.3. Because again, remember sigma here is going to be 2.3, right? So then I add again for the next one, and I get 36.3. And then for the last one, I get 38.9. All right, those are the standard deviations to the right. All right, if I go to the left, I'm going to get 29.7 for the first standard deviation. Then I'm going to get 27, let me change colors, 27.4. And then if I go one more, I'm going to get 25.1. All right. So you need to label your graph, or your bell curve like this. All right. Now, the question says, the first one, what interval does 68% of the data lie in? All right, so the interval will be the range, okay? So if we say 68%, remember, will be this first set right here, 68%. And so we would say between 29.7 and 34.3. So 68% will give us a range of 29.7 and 34.3.
All right, Coach. Last time I came for it.
All right, then for 95%, all right, you would look at your intervals again. All right, 95% is going to be 32 with 2 standard deviations, so you have 27.4 to 36.6. All right, and then for 99% or 99.7%, you have from 25.1 to 38.9%. All right. All right, so again, man, it looks like this. All right. So make sure you know, man. All right. 68% between 1 standard deviation, 95%. All right. 95% between those 2 standard deviations, 1, 2, 1, 2. All right, and then 3 standard deviations, 1, 2, 3, 1, 2, 3. That's 99.7%. Okay. All right, so this is what it will look like. All right, those are your intervals. All right, last couple of questions. We have to look at. Oh, hold on, let me clear it out because we just did this in class. All right, this part right here, it says the height of a sample of 24 apples are from an orchard are given below in pounds. All right, the mean is 0.5 and standard deviation is 0.08. Does this data appear to be a normal distribution? All right, if you guys remember a normal distribution, right, if you have the mean, right, and I can go back to one of these other examples. All right, this is the mean. Half the data should be on this side, half the data should be on this side. All right, and that's what we're going to do. We're going to see if half the data is on one side and half the data is on the other side. All right, so we know that the mean is 0.5. All right, mu is 0.5. All right, so mu is 0.5. So we're going to look and see if half. All right, let's see what's above. That's above 0.5, above 0.5, above 0.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right. So 13 of these weights, all right, 13 are above 0.5, all right, above the mean. All right, well, it's 24. So let's do the math. 24 minus 13 is 11. So there are 11 below 0.5. Well, guys, on a normal standard deviation of 24, it would be 12 and 12. All right, how far from 12 and 12 are we? We're only one off. So this is pretty normal, guys. This is a normal distribution. All right, it's normal because, again, how far are you from, half being, if you had a bell curve, all right, half being on this side, half being on that side, all right? You're not, all right? You're not far, okay? But let's look at this other example right here, all right? There's 20 people, all right? They're singers in the choir. The average age is 40, all right? Mu is 40, all right? The average is 40. So let's look and see how many are older than 40, all right? So we have 1, 2, 3, 4, 5, 6. All right. 6 people are older than 40. All right. 6 people above 40. All right. And then it's 20 people. So that means 14 are below 40. Right. So this is clearly skewed. All right. See how there's more people on the lower end? All right. So where you wouldn't have a normal distribution, you don't have that. What you have now is called skewed distribution. All right, there's more people on the back end than right here in the middle where 40 is. Right, there's more people on this side. So this is skewed right. And I say right because, again, there's the tail. You look at the tail. Where's the tail? It's on the right side, so skewed right. This is not a normal distribution. Okay, not a normal distribution. Man, that's it. That is your quiz review, okay? Hope this helped, man. Good luck.